Hi guys, welcome back to the channel. So today we have another topic that is about subnetting. So before going to start my video, make sure that you subscribe to my channel and let me start. So let me ask you one simple question. So you have your smartphone, right? And your friend is also having a smartphone. So your neighbor has a so all of you live in the same building. But when your Swiggy delivers your food, so how does that delivery guy know it's you, not your neighbor? Because you have specific flat number and specific address, so that is only yours. So that is exactly what this subnetting is doing for every single device on the network. So and today I'm going to explain this so simply using this simple diagram. And even if you have never studied networking in your life, so you will understand it completely. So let's get into it. So look at this diagram. So this is a smart nagar, a brand new township. So smart nagar has four different blocks and one block A is residential, and block B is for shop, block C is for school, and block D is for hospital. So the government has gave a smart nagar one internet connection. So that is 256 addresses. Okay, to distribute among each blocks. So the main router said, no problem. I'll divide this very simplest man. So the smart division, what is that smart division we call here in networking? That we call it as subnetting. So before we go inside each block, so let me explain you the most important thing in subnetting. So you must have seen these numbers, right? 24, 26. So that we'll see first. So this is like 192.168.0.0.24 or 192.168.0.0 subnet 26. So what is this 24 and 26 here? So let me explain this right now once and for all. Every IP address have 32 total 32 bits. So think it like a 32 boxes we have. So one 8 bits inside that. For 168 we have 8 bits, and for 0 8 bits, and for 0 8 bits. So total we have 32 bits. So now the number after slash, that is 24 and 26, tells you how many of those 32 boxes are locked for that particular network. So we have very simple rule here. So that locked box is equal to network part fixed. So nobody touches that remaining box we have free for the devices to use. So first we'll take this 24 as example. So 24 means we have 24 boxes are locked here, and 8 boxes are free, and 8 free boxes is equal to 2 to the power of 8. That means 256 total addresses we have. You can see here total we have 32 bits. That means 24 are locked. So 32 minus 24 will be having 8. So that means 8 boxes are free here. So 2 to the power of 8, that means 256. So in this 24 subnet we have 256 addresses. So when we come to 26, again you can see here 32 minus 26, that means 6. So here 26 are locked, right? So that means 32 minus 26, 6. So 6 boxes are free here. So 2 to the power of 6, 64 addresses we have. So to remember this, you can take this as example. Like imagine we have one whole pizza with 24 subnet. That means we have 256 slices there. And for 25 subnet half pizza, that means only we have 28 slices, right? So this is all 20 subnet 24 and 26. So pizza slices, so nothing more. So next, when we come to the division part, so now look at this main diagram. So that is router. So router, so subnet 24. That means we have 256 addresses here, and A block A, that is a residential area. That means we have 64 addresses. And for block B, we have 64 addresses. And block C, we have 64 addresses. And block D, we have 64 addresses. This is clean, equal, and organized. No wastage here. So you can see here the definition. Subnetting is a process of the dividing one large network into smaller and manageable subnet. We call it as subnets. So that divides are organized and the traffic is controlled and the network rules faster and it's more secure. So for first we'll see for block A. So block A, that is for residential, we have 192.168.0.0 and here first block, that is first IP address is reserved. First and last are reserved. So last we have reserved that we call it as a broadcast IP. So first address, that is 192.168.0.0. So this is reserved as a block name, like and the last address is also reserved as a broadcast. In total, here we have 62 addresses which go to the real houses, right? So house 1 192.168.0.1 and house 2 192.168.0.2 and house 3 192.168.0.3 until 192.168.0.63. So this is for block A. And when we come to block B, shops. So first IP address start exactly where the block A ended. That means 63. So again here we are starting from 64. So this first address is reserved. Even last address is reserved as broadcast IP. And for shop 1 we have 192.168.6.0.65 until 127. Right. So next block C will. What is this block C? So block C is for school. So school first IP address starts with where the block B ended, that 127. That means here we'll start with the 128. So 192.168.0.129 until 192.168.0.191. So here, even here, first and last IP are reserved. Next for block D, that is for hospital. So the most sensitive block is this because every like patient data about everything will be storing here, right? So for doctor cabin, IP is 192.168.0.193 and until 255. Even here, first and last IPs are reserved. So this is about the network address dividing, that is subnetting. So we you can see here, you can see those four arrows from the main router. Each arrow is a wall, right? One, two, three, four. You can see here these arrows. For house in a block A trying to reach the patient records in a block D. So that means it is blocked. Then if the doctor cabin is trying to reach the pharmacy, then both are in the D, right? That means they both are in the same network. So that is totally allowed. So if there is a same block, then talk freely. If there is a different block, then it's invisible wall for you. So you can ask me, okay, Nisha. So we got IP address, we got a network. So we have divided and we have distributed among the different blocks. So everything is good. Then why we ever need this? So imagine a smart city without a subnetting. So all 256 IP addresses in one big hole. Everything mixed together. So first, what is a problem one will be getting about security? So if a hacker connects to this shop's Wi-Fi, sees patient record. So salary data, it may be a private house files or it may be files exposed. Everything will be exposed here, right? So second problem will be getting about speed. Every device talking to every other device constantly. So that means hospital server sending the announcement to the house one and house one laptop and school computers sending the data to the bank, right? So never get slow. It's like congested. So what is the problem three will be getting about management? So if IT team gets a complaint like why device has a problem, so nobody knows. Which 256 devices all were mixed, right? So finding one faulty device is like finding one person in a crowd of thousand, right? So with subnetting, all three problems were sorted. Like when we come to security, each block is sealed, so hackers stays trapped. And when we come to speed, so traffic stays inside only its own block, right? So fast and it's very smooth. So when we come to management, if there is a problem in only block C, so then IT team will goes directly to the block C and fix it in a minute. So the things will be easy, right? So this is about the subnetting. So today we covered everything like what is subnetting, so how smart city divided the 256 addresses in four different blocks, and what is subnet 24 and 25 actually mean, and why subnetting is not just a theory, it is a real world necessity. So this is all about the subnetting. So if this video finally made submitting easy for you, then hit that like button right now. So drop a comment below. So which block of the smart city would you live in? And share this with the one friend who is struggling with the subnetting. So you will save them hours of confusion, and subscribe so that you will never miss this simple visual breakdown. So until then, so see you in the next video.